Welcome to Keys Consumer Math and Personal Finance, Section 1.3, Percent of Change. Before we talk about percent of change, I want to review a little bit about what we learned about percent in the last video. Remember, percents are ratios with a denominator of 100 or per 100. But percents can be written as a percentage, a decimal, or a fraction. We're going to practice converting fractions to decimals and percents right now. So I'd like for you to look on page 8 at example 1. It says express 1/400 and 7/5 as percents. So let's go ahead and do that. 1 divided by 400, that's a fraction. If I want to convert it to a percent, I have to first convert it to a decimal. This means 1 divided by 400. When I divide 1 by 400, I get 0.0025, or 25 10,000ths. I want to convert that into a percentage. Now, when I go from a percent to a decimal, remember I divide by 100 and move the decimal 2 places to the left. But because I'm going from a decimal to a percent, I'm going to multiply by 100. So I'm going to move my decimal 2 places to the right. So this decimal, 25 10,000ths, converts into 25 hundredths of a percent, or 0.25%. And you'll notice that that is less than 1%. It's okay, we can have percentages that are less than 1%. Now let's look at the next one. It says convert 7/5 to a percent. So I'm going to convert my improper fraction 7/5 to a percent. First, I'm going to divide. 7 divided by 5 is 1.4. And again, I'm converting my decimal to a percent, so I move the decimal place 2 places to the right. I need to put a placeholder in here. So this becomes 140%. You'll notice that this is greater than 100%, more than a whole. It's extra. That's okay. You can have percentages that are bigger than 100%. I'd like to review finding the percentage of a number. If you look on page 9 in example 2, it says the fee for a traveler's check is 1.5% of the face value. Find the fee for $3,500 in traveler's checks. Now this is one of those problems where we're looking for either the percentage, the base, or the number. We know the percentage, we know the original number, so we're now looking for the result. It says 1.5%. Well, we're going to convert that percent into a decimal by moving the decimal 2 places to the left, so that's going to be 0.015. That's our percentage of our base, or 15% of 3,500 is what? Is Rn. So when we multiply 0.015 times 3,500, we get $52.50. So the base fee for a traveler's check that's $3,500 is an extra $52.50. I would like for you now to pause the video and study example 3 as a review. Welcome back. Now we're going to talk about percent of change. Percent is often applied to change in value. This could happen, for example, when the quantity of an item rises over a period of time, or when the price of an item is reduced for sale. It can also happen when a population has grown or decreased, or we use it in sports, as we'll see a little bit later. In order to calculate the percent of change, you have to know a couple of things. The first thing you need to know is the amount of change that has occurred. And the other thing you need to know is the original amount. Once you know these things or have figured these things out, then you can use our base formula of percent times base equals n to solve for our percent of change. For example, if the price of an item rises from $75 to $90, find the percent of increase in price. So first we're going to take our larger amount, which is $90, and we're going to subtract 75 from it because we need to know how much it's actually increased. It's increased by $15. That's the actual amount. That is number one, the amount of change that has occurred. But I want to know what the percentage is. So I need to know my original amount. My original amount in this case was $75, not $90. So what I'm going to do over here is I do not know what my percentage. So that's going to be my variable. My base is 75%. That was my original price. And now I'm not going to put a 90 over here. I'm going to put a 15. A 15 was my change. So percent times 75 equals 15. When I divide both sides by 75, I get P equals 0.2. That's not a percent, that's a decimal. I'm going to convert it to a percent by moving my decimal 2 places to the right, and that ends up being 20%. So my percent of increase was 20%. Or another way of saying it is the change in price from $75 to $90 is a 20% increase. That is the percent of change. It may be easier or quicker, though, to think of that problem as a change of ratio. It's the same thing, but you don't have to think through so many steps. You could do it by taking the amount of change divided by the original amount times 100, and that will give you the percent of change expressed as a percent. In other words, the amount of change in our last problem was 15%, was $15. We divide that by the original 75, multiply that by 100, and we get 20%. It's the same thing, we just do it in a little bit of a faster way. Let's look at another example. If you look on page 10 at example 4, it says, from the example that we just did, assume the price of $90 was reduced to the original price of $75 a month later. What is the percent of decrease? Do you think it would also be 20%? Well, let's find out. The amount of change, again, was $15. We went from 90 down to 75, so that amount of change was $15. But now our original amount is 90. It decreased down to 75. So now we're going to divide 15 by 90 and then multiply by 100. And when we do that, we get 16.7%. So it is not a 20% decrease now. It's been a 16.7 decrease because we're dividing by a different amount. I would like for you now to pause the video and study examples 5 and 6 on page 10 and then come back. Welcome back. Let's do a couple more practice problems together. First, let's practice converting from decimals to percents and fractions to decimals and percents to fractions and decimals. Each number has 3 forms, a percent, a fraction, and a decimal. Find the other 2 forms from those listed. So the first one is 138.2%. It's easy to convert that into a decimal. We just move the decimal place 2 places to the left. So that becomes 1.382 as a decimal. But in order to convert it to a fraction, I've got to think a little bit. This is 1 and 382 thousandths. So I could put 1,382 over 1,000 because this is the tenths, hundredths, thousandths place. And when I reduce that, I reduce it to 691. They're both divisible by 2 over 500. So 138.2% is bigger than 100%, so it's going to be a decimal that's bigger than 1 and a fraction that's an improper fraction. Same thing would happen for 24 over 17. I'm going to let you do that one on your own because we already practiced that earlier. Let's do number 3 together. If we do number 3, it says 0.85. I want to convert that to a decimal, a percentage. If I do that, I just move my decimal place 2 places to the right in this case. So I get 85%. That's a normal percentage. Now, in order to convert that to a fraction, I take that 85 and I put it over 100 because remember, percent is per 100. And when I do that and reduce it, 5 goes into both of those. It goes in there 17 times over 20, and that becomes a fraction of 17/20ths. I would like for you to try number 2 and number 4 on your own and bring it to class tomorrow. I would now like to do some application problems. It says answer each problem to the nearest percent. So we're going to try number 5 here. Number 5 says, 3 of the 12 largest cities in the U.S. have decreased in population since 2000. Of these, Detroit is decreased the most from its largest population to another number. Find Detroit's percent of the decrease. So what we're going to do is first we have to find the difference between those two numbers. So 1,849,568 minus 673,000. That's a huge decrease. 104. When I subtract those two numbers, I get 1,176,464. Now, I need to figure out what percentage that is of the original. So I come up here to my blank percent of, because I don't know my percentage, of the original 1,849,568 is 1,176,464. Okay, that is the same thing as saying P times 1,849,568 equals 1,176,46. I forgot a 4. 464. Right? Yes. Anyway, when I do that and I divide both sides by that 1,849,000, I get my percentage, or the decimal, as 0.636. I want to convert it to a percent, so I'm going to move my decimal place 2 places to the right. That gives me 63.6%, which says to round to the nearest percent, so that's 64%. That is a 64% decrease in population. That is huge. I would like for you to try number 6 on your own. The last problem we did, we followed all the original steps. This problem, we're going to just do the change in ratio formula. Really, it's the same thing, but it's just faster to think of it this way. Number 7 says to answer each of the following in the nearest tenth of a percent. Number 7 says in 2001, Barry Bonds with the San Francisco Giants set the record for home runs in a season with 73. Find the percent of increase over the previous record of 70. Well, the difference between 73 and 70 is just 3, so that's an easy difference to figure out. My original record was 70. It changed to 73, but my original was 70, so that's what I'm going to put there. And I'm going to multiply by 100, and that will give me my percent automatically. When I divide 3 by 70 and multiply by 100, I get 4.3, because I said to round to the nearest tenth, percent increase. So his record was increased the previous one by 4.3%. I would like for you to try number 8 and 9 on your own and bring all of those problems to class tomorrow.